Go ahead and pause the video and try this warm-up problem where I give you the equation and I want you to identify the four pieces. So hopefully you paused the video and then you were able to come up with the following. Your A value was 1 because that's the number in front of cosine. So the absolute value of 1 is 1. There's my amplitude. Remember, B is the number that's in front of X, so that was 4. Your period is 2 pi divided by the absolute value of B. So absolute value of 4 is 4. So 2 pi divided by 4 means that pi over 2 is our period. Our phase shift is always going to be C divided by B. So remember, C is the number that's in the parentheses. You have to change the sign. So since I see a negative pi in parentheses, positive pi is C. Since B is 4, pi over 4 is the phase shift. And then your vertical shift is whatever D is. D is the number that is not attached to the cosine. You always keep the sign the same, so that's why it was negative 3. All right, so we're going to continue with graphs of sine and cosine functions, but today we are going to be giving you a graph or giving you an equation, and we are going to ask you then, or not give you an equation, give you different pieces and have you write the equation. Okay, so modeling periodic behavior. Sometimes we're asking to look at a function's graph and write the equation. So when doing so, we're going to want to identify those key characteristics, just like we did in our warm-up where we found the amplitude, the period, the phase shift, the vertical shift. Okay, that's the crucial information. Like I mentioned, other times you might just be given some of those key characteristics and then you'll be able to write an equation based off of that. So let's take a look at this picture. Find an equation of the form y equals a times the sine of bx that produces this graph. Okay, so the first thing that I notice is that they're wanting the most basic of basics. There's no phase shift and there's no vertical shift. So we just need to figure out what is our amplitude because that's going to be in relationship to A. And then what is our period because that's in relationship to B. Okay, because we're talking about a sine graph, it's important that we can identify the 5 critical points, and then that way we can figure out our information. So remember, when you're talking the sine graph, you start at 0, 0. So here's 1 point. The second point would be up here. Third point is back on the x-axis. Fourth point is down, and fifth point back on the x-axis. Okay, so notice that from my starting point at 0, 0, we were able to get a height of 4, okay? That is going to be your amplitude. And once again, remember, your amplitude comes from your A value. And your most basic sine graph always goes up first. That's when your A value is positive. So I know that right now it's going to be 4 times the sine of something. Now we just have to figure out B. So remember, if I can start at 0, 0, notice that where I'm ending on the x-axis is pi over 2. So that means that that is my period. So my period is pi over 2. Now, if you remember, the formula to get to your period is always going to be 2 pi divided by the absolute value of b, or just let's just say b in this case. Okay, so what I'm going to do is I'm going to take this proportion and I am going to cross multiply, and that's how I'm going to solve for b. So when I cross multiply, I get b times pi, and that's going to equal 4 times pi. So to get b by itself, I'm going to divide both sides by pi. And so look at that. My b value is going to be 4. So that's the number that I'm going to put into this as well. So it looks like this graph comes from the equation y equals 4 times the sine of 4x. All right, let's do the same idea, but now let's look at a different graph and let's write the equation for cosine. So we have, once again, to identify A and B, we are just going to want to make sure that we know where our critical points are. So remember, with the cosine graph, we start at the top. Okay, there's my first point. We touch the x-axis, then we're down to our lowest point, then we're back at the x-axis, and then we're back at the top. Okay, so those are my 5 critical points. So then remember, my height is going to be from the highest point to the x-axis. That's what we then have as our amplitude. Well, notice that it is a distance of 3. And this is, once again, what a normal cosine graph looks like. It starts and ends at the highest point. So that is then going to tell me that my a value will stay positive 3. Okay, so then once again, it's just a matter of figuring out what my b value is, and I have to identify the period. So from the first top point to the last top point, this distance right here is my period. So notice how I'm looking at then 4 pi. So if 4 pi is my period, I am going to set that equal to then the formula for how we normally calculate period, which is 2 pi divided by b. So what I'm going to do is I'm going to make 4 pi a fraction by putting it over 1. And so then once again, we have this proportion. I'm going to cross multiply and solve for b. So when I cross multiply, 4 pi is getting multiplied by b, and then 1 gets multiplied by 2 pi. So then I need to divide both sides by 4 pi so I can get the b by itself. So then notice how the pi's cancel, and then 2 over 4 is going to simplify down to a half. So it looks like y equals 3 times the cosine of 1/2 x. This is the equation that allowed us to get that picture. All right, so now let's create an equation just based off information. Excuse me, and not a picture. Okay, so this time they want us to write the cosine equation. So notice how I also have phase shift thrown in here. So remember, our basic definition for cosine is a times the cosine of, in parentheses, bx minus c plus d. Okay, so our goal is to figure out what a, b, c, and d are from this information that's given. Okay, so I will tell you this. When you don't have a picture and they're giving you the amplitude, once again, it's always the absolute value of A. And so in that case, we don't normally know if it's a positive or a negative number to actually represent A. So when there's no picture, we're going to assume that it is the positive number. So right now, I know that 3 is going to start us off. Okay. So phase shift, remember, we get the phase shift and it says that it's to the left. So technically, to the left means that it's a negative. So this is a negative pi over 2. And so when that's the case, remember, that's always c divided by b. So I have to know what b is first before I can find c. So that means I'm going to go down to the very last one here where it says period. So if my period is pi, we're going to set it up like we did with those other ones. So I'm going to make pi a fraction by putting it over 1. And then my definition for how I calculate pi is always 2 pi divided by b. So I'm going to cross multiply here and solve for b. So when I cross multiply, b gets multiplied by pi, 2 pi gets multiplied by 1. And so then if I divide both sides by pi, that tells me that my b value is 2. So I know that 2 is connected to x. All right, so now I get to take my negative pi over 2, which is the phase shift, and I get to set that equal to c divided by b. But guess what? B is 2 because we just calculated that. So now I have a proportion where I have my one unknown. If I cross multiply, we'll get negative 2 pi to equal 2c. To get c by itself, I got to divide by 2. And so c is going to be negative pi. So notice that when I put negative pi into this problem, I'm subtracting a negative pi. So that's why it's a positive pi in the parentheses. Because once again, if I'm shifting to the left, we have the opposite sign in our parentheses. Okay, and then because nowhere in this problem it mentioned a phase shift, it mentioned a vertical shift. Remember, your vertical shift is your d value. So you don't even have to put plus 0 because that's what d is. So this right here would end up being my final answer. All right, so see if you can pause the video and try this checkpoint problem. The amplitude is 5. The phase shift is pi over 4 to the right. The period is 3 pi, and I want us to find the equation for the sine. All right. So, once again, notice that because I don't know what the absolute value of my A is, I don't know if A is positive or negative. So, when there's no picture, you're just going to assume that it's the positive. So, A was 5. We couldn't find the phase shift until we found the B value. So I needed to find the B value based off of the period. So remember, 2 pi over B is going to equal 3 pi. So if I put that over 1 and I cross multiply, I ended up then having to divide 3 pi. And so 2 pi divided by 3 pi made my B value 2/3. So now that I have that, C divided by B is my phase shift. So because it said that I was going to the right, that means that I wanted that fraction of pi over 4 to be positive. So C over B equals pi over 4. So I placed B with 2/3 because that's what we calculated. So then there's a couple different ways you can think about this. Remember, if I just focused on this part of the equation for a second, notice how when I'm dividing by a fraction, it is equivalent to multiplying by the reciprocal. So I just ended up writing it as then 2/3 C. But then how do I get rid of C, or how do I get C by itself? Well, then essentially that just meant that I multiplied both sides by 2/3. So then those numbers disappeared, giving me the C by itself. And so that's why I ended up with 2 pi over 12, which reduced down to then pi over 6 for C. So then remember, when I have my C value, I have to put it into the formula where I'm subtracting C. So that's why in parentheses, I see a negative pi over 6, even though I'm moving to the right. And then because no vertical shift was given, once again, my D value is 0, so I didn't have to do any adding or subtracting. But remember, if I did give you a vertical shift and I said it was a vertical shift up, well, then you would need to add that number. If I said it was a vertical shift going down, well, then you would need to subtract that number. Okay, so that is us modeling periodic behavior.